All right. So this is now being recorded. Good evening, everybody. So the purpose of today's session is to help you get started with R. And that's what you're gonna use. You're gonna use RStudio for your course assignment. So here is the agenda for today. I will go over what is R and what is RStudio, and I'll show you the environment and the interface. I'll show you how to save your commands into a script, how to use variables, how to read data from the file, and what's a data frame. Then I'll show you how to look at the data subset, how to add variable, delete variable, and so on. Data visualization, and the bonus is some useful resources, but you need to stay or watch the recording until the end. And then we have some question and answers. Hopefully you have some good questions. Here is a link to data set that I'm going to use in this demo. And basically, the data set tracks the employee satisfaction level and the number of years after the last performance review, number of projects worked on, and etc. And based on that, we want to determine if an employee left or stayed in the company. So that's a data set I'm going to be using today. But before we started, it's very important, we never discussed what R is. R is a programming language for statistical analysis and data visualization. Now, this is free and open source. And as you may have noticed, it's available for different operating systems, like if you're a Mac user or if you're a Windows user. Now, excellent data visualization capabilities and advanced statistical method. Then you might make your work reproducible just by saving the commands in a script, right? And you may share the results with others. There is a very powerful documentation. Then it works really well in the academic environment. You can also use it with databases, which you will see later in the later courses. Then you may produce the same result more than one way and then the parallel processing support. Now, you might be wondering, what are some drawbacks? Well, R itself does not have a nice graphical user interface. And of course, it has some learning curve, right? And you need to learn how to read the help pages. It's case sensitive. It may not solve all the data mining problems. You need to keep on updating your packages regularly, and this is very important. You need to have the local admin rights to install R and RStudio, okay? Make sure that you're using the PC where you have admin rights, or at least you're able to enter the username and password, admin username and password if prompted. Well, another drawback is the performance. It's slower than Python or Java, okay? So what you need to do to get started is that you have to install the latest R version, right? So that's for Windows, that's for Mac. And after that, you have to install the RStudio. So that's an interface that we're going to be using. It's running on top of R. It's running on top of R. And it has some interface, right? Okay, so what is RStudio? This is an integrated developer environment, and it makes your work a little bit easier, right? And you can preview environmental variables and functions. Well, there are nice tabs where you can preview the values of your variables. However, I'll show you why, and I would strongly recommend that you do your work programmatically and save all commands in a script. That way, your work is very easy to reproduce, right? All work that you do needs to be reproducible. And I'll show you exactly what I'm talking about. This is my R, right? Sorry, this is RStudio. And this is what it's going to look like, something like that when you install it. The window here, this is called the console. So here is the window where all your commands will appear, and the commands output, the warnings, the error messages, right? It will show in this window. In here, you have several tabs. The first one is the environment. So that shows you anything that you have in memory at the moment. And at this point, I don't have anything. And then, oops, I need to click share again. And then what you will see is you will see the commands history. It's on the next tab, right? So if I go in here, if I click on the history tab, here this is showing me the command history, right? So this is something that I ran before the presentations, perhaps, right? So what I have here is I have files tab. So these are the files that I have in my currently selected directory. That's called the working directory. This tab is where my plots are gonna appear. This tab is packages, and there are two types of packages. There is a system library and user library. So package is basically a set of functions that are combined together. Set of functions, and it may contain some help pages, and it may contain some sample data sets, right? Now, there are two types. System library is what's pre-installed, and the user library is what you install, right? And the first package that you're going to install is called rules, and I'll show you how to install, right? So this is a help tab. So you can run a search topic here and just read the documentation, or I'll show you how to do it programmatically, all right? So just remember this package, these tabs. Now what I'm gonna do is I could run my commands in here if I wanted to. But the problem is anything that I run in here is not reproducible, right? I cannot reproduce my work easily. And most of the time, most of your homeworks cannot be done in one sitting. So what you want to do is when you sit down to continue working on your assignment, you want to be able to easily get back to where you stopped. So the solution is this. You're going to do this file, new file, and this is called an R script, right? So you're going to type all the commands in R script, and you will save this file on your hard drive, right? Save, and then you choose the location where you want to save it, right? You choose the location where you want to save it. But what I did today for you is I prepared the code, I prepared the script. So to open existing file, I would just go File, Open, and then I'm going to browse to the location where I save it. There is an alternative way. Suppose that you don't remember where you save it. Watch here, File, Recent Files. And here you'll see the list of files that you recently had opened. And this is my file, okay? Well, this is the code that I wrote for you. And I'm going to go over the commands now. Okay, first thing that you see here, this hash followed by this text, this is a comment. The purpose of the comment is to describe, well, it's to document what my code is trying to do. And this will be helpful for me too, because tomorrow if I have to go back and edit it, I would know what I was doing, right? Well, it's also a way to document it. And then when I share the code with you, it will help you see what I did. Now, this is the first command. What it does is it checks the R version. Which version is installed in which version is currently installed in your PC. To run this command, you would just put a cursor here and you would click Run. This will execute the command, and then the output, well, the command output will be displayed in here, in this console window. In this case, you see that the command output is the R version that you're using, right? So this is 353, this is the latest one right now. Similarly, alternatively, you can run version, right? It's the same thing, it returns the same output, version command. Session info, this one will give information about your session. So that's not only the R versions that I'm using, well, this will also show me the language and all of the packages that I currently have in memory. Well, remember packages, these are the set of functions, and well, when you see this, right, do you see this checked? It means that this is right now in memory. But when I type session info, it also gonna give me, it also shows me what's in memory, right? Plus some other stuff here, right? So now you know that. ls command is going to show me everything that's in my memory. So take a look at this. If I go back to my environment window, right, it's going to show me everything that's here. That's a programmatic way. So I'm going to hit run right now, and well, right now I'm going to see not anything. I'm not going to see anything, no output, and the reason is that I don't have anything in the environment. Well, I have not done anything. I have not saved anything, right? Now what I'm going to do, well, this is an alternative way. You can type in objects and it's the same thing, right? It's another way to do this. Data is going to tell me which data sets I have pre-installed. This is a set of pre-installed data sets. And I think for your homework, for your first homework assignment, you're using the Iris pre-installed data set. It's in the data package, right? It's in data sets package right here. Now what you can do is you can use your R as a calculator. Well, see this 5 plus 9 equal 14. Notice this number 1. Well, everything in R is a vector. This here, it means that this is a vector of one element, right? Well, see, well, number 1 means that the first element that you see here is at position number 1. Elements of a vector are numbered starting from 1 in R. Now here, this one will just output the text, welcome to data mining, and do you see this one again, right? It's because everything in R is a vector. So now, I still don't have anything in my environment. It's because I did not assign anything to a variable. So this is how you do the assignment. X is my variable name, and then less than, minus, and then 3, right? So this thing here, right here, this is an assignment operator. I'm going to create variable X and assign number 3 to it. That's it, right? Nice and easy so far. And this edit X here, and the value is 3, right? So now if I go back and run ls, now it's going to show me that I have X, right? What I'm going to do next is I'm going to print the value of X. And to print the value of X, you can just type X, right? You can just type X, it's a shortcut. Now here, I'm going to do two things at once. I'm going to create my variable called Y. I'm going to assign 5, and I'm also going to output the value of Y. So if you put this in parentheses, well, first it's creating this, assigning 5, and then it's gonna output, right? So now if I do this, just imagine I don't have this nice window. To verify that I have two variables programmatically, I can just run ls command. And this will show me that's what I have in my memory now, right? Suppose that I no longer need X. I can run rm command and specify what I want to remove, right? Well, and this is going to be, I'm going to remove X. X is no longer in here. An alternative way to do that is this. See that this is in the list view. I can change it to the grid view, and I can select a check mark here, and I can click the broom. That's another way to delete my variables from the memory. But, well, Elena said you have to do everything programmatically, because you want all your work should be reproducible, right? Because if I just did that, then I would not have had this command in my script, right? What this will do here is that this will remove everything that you have in your memory, right? rm is to remove, ls, list everything that you have in the memory, right? So here is the list, and it will be removed. I'm gonna run that, and now this disappeared. Options command will return my environmental options that I have, right? Like for example, this is when R displays a warning, this is the number of characters to show. So if the warning is longer than 1,000 characters, it's going to show the first 1,000, right? Some of you might be thinking, how do I clear the screen? So one way to do it is a Control L. So you press Control L simultaneously. Or, well, I think in Mac it's Windows, right? Well, in Mac there is no, not Windows. In Mac there is a different command. It's not a control. It's something else, okay? Now, alternatively, you can run this command. You can run this command here, right? I believe it's a Command L, something like that. Def off, what this will do, this one will clear all your plots. Well, yes, so sometimes you have a lot of plots, right? And you want to delete all of them. This will delete all of them. Well, okay, well, yeah, well, this is an error. Well, it might be because I don't really have anything. Okay, now let's look at the history. This will show, well, especially the last 5 commands in the history. What this command will do, this is a C, which stands for combine. It's going to create a vector of 5 elements, right, 1 through 5. And here is a shortcut. I want to create my elements 1 to 5, and I want to assign to an X, right? So this will create X and assign. Now I want to display what my X is. Well, this might sound like basic, but well, we need to understand this first, because this, something small like this, will be part of big command soon. Okay, so now, if I want to display only the third element, right, I have to do this. I have to specify the index, right, the position of the element, and remember that the numbering starts from 1 in R. So I'm gonna do this. This will show the third element. Class X is gonna show the data type, and this is another way. str will show the structure. Well, in this case, it's just an integer, but this command becomes very important when we start reading the data. Here, well, this will create a list, but this time I'm gonna have elements 1 through 5, and then I'm not gonna have 6, 7, I'm gonna have 8 through 10. So this is my Y, right? And then to verify, I'm gonna do this. Now suppose that I want to show only elements 3 to 6. This is what I do. In that brackets, I specify 3, column 6, right? This is one way to do that. Now class Y, well, that's gonna show me the, well, this shows that it's an integer, and this one will show the structure. Now what I'm gonna do is I can multiply by 2. Well, this will actually multiply every element by 2, right? It'll multiply every element. Here are the sequences. Well, this one, what it will do is it will create an element starting from 1, and the step is 1 by default, right? So this is a sequence. Here I want to create another sequence, but I want to start from 2, right? I can specify what I want to start. And here I want to start from 2. I want to go up to 10, but I want to increment by 2, right? So I want to do that. Okay? So now I'm going to show you more on getting help. Well, see that this is a help tab, right? Well, you can type your commands here and you can search for it, right? You can run a search here. For instance, you can type on bar plot and see the pages that contain information. An alternative way to do that is you can type simply this question mark and the word bar plot, right? If you just run the question mark and the bar plot, this help page will open and you can read about the package, right? Like usage and different input parameters that it takes, and there are some examples. Well, over here there are some examples on how it's used, right? The same thing, you can type the word help and then the bar plot in parentheses. Now let's imagine that I don't know how to spell bar plot, but I know that it starts with the word bar. What I could do is I can type this command apropos, and this command is going to show me all possible searches, right? It's gonna show me everything that contains the specified string, right? Well, in this case, bar. See this? Everything that contains bar. And then if I see what I'm looking for, I'll just type question mark and the command, right? But this is in general what you do if you're not sure about the spelling and so on, right? Well, this one, if you type example bar plot, it's gonna display the set of examples, right? So I'll let you play around with this. And here, this will just show the hub page in a browser, right? So now what we're gonna do is we're gonna get to the fun stuff. Well, we're gonna read the data from the file. That's a file that I was talking about. That's employees data here, right? I have this data stored in a CSV file, but on my hard drive I have a folder and I called it data sets, and that file is stored in that folder, in a folder called data sets. So now what I need to do here is that I want to read my file in R. How am I going to do this? Well, first of all, I must set the working directory. Well, the working directory is a folder where R is going to look by default, right? It's a folder where R will attempt to find the file by default. And the command is set wd. That's how you set the working directory. Let me run this. How do I verify that it's set correctly? Get wd command is going to show me what my working directory is. Well, in this case, this is a working directory, right? Also, well, look at this here in this bar. Right here, it says what my working directory is. That's another way to show. But I want to do everything programmatically because I want to be able to reproduce my work, right? I want to be able to reproduce my work. Now here, this command will list the files that I have in the working directory. In this case, I just have one file. Now here, you can check if the file exists. Well, sometimes the problem is you have a long list of files and you're getting some errors when you try to read data. So you want to check within R, you want to check if the file exists. So this is how you do it, right? This is the file name, and file exists command is going to return true if my current working directory has this file. So now what I'm going to do is I'm going to read the data from this file, right? And I want to read this into HR data frame. Well, HR is a data frame, right? It's an R object that I'm going to create. And I'm going to assign the data that I read from the file into this variable, right? What I do here, the first parameter is a file name. Header equals true. It means that my first row in a file contains the column headings. I want my column headings to be read from the first row in the file, right? And the separator comma means that the file is a comma delimited, right? Well, it's a default, but sometimes I don't like to rely on default. I like to explicitly specify, okay? So now what I'll do is I'm going to run this command, and if you notice that, I'll show you both. If you go to the environment, well, see this HR, and if you see here, it shows me how many rows I have and how many variables I have, right? So this is the size. And I can expand this, and it's going to show me the structure. Here as a list of my variables, and here as a data types, and then I see, well, the first few rows, right? I see the value of the satisfaction level in the first row, in the second row, and so on, right? But the problem is I want my work to be reproducible, of course, right? So I'll show you how to preview your data programmatically. Well, one way to do it is to run the view command, right? View command will open the data in a tabular view. I'm gonna do view HR. Well, notice that it will open this, right? Well, it's nice, it's tabular, but you know, okay, this is good, right? This is just good for the preview purposes, but let me show you something else. Well, this command is going to be your friend. Trust me. Head command is going to display the first 6 rows in the console. Sometimes you want to preview what your data actually looks like. And the data set is huge. You don't want to print the whole data set, right? So you would want to just use head command to print the first 6 rows. Now what's happening here is that my variable names are too long. And this does not fit on a single line. So R will wrap for me. It will wrap the rows for me. 6 is a default, right? The head command returns 6 rows by default, but if I want to see more rows, well, this is a second parameter. I specify the number of rows that I want to see. And the tail command does the opposite. It will show the last 6 rows or the last number of specified rows, okay? And now what we'll do is we're going to look at the DataFrame properties. Here, I showed you how to see the structure, right? But let's imagine that you're using an environment where this window is not available. You're going to run the str command, right? The str command will show the structure. Well, this is similar to what I see here, right? What this means here, department is a factor variable. Factor, it means that it has the specific set of values, right? Categorical. And for example, I have 10 departments, right? They're known in advance and they are discrete, right? Each department here, so to speak, has an index, right? So accounting is 1, HR is 2, right? So what 8 here means that it's an individual is working for the department at level 8. So it's gonna be the 8th one that's listed here. Well, it's a little bit hard to see. Let's look at the salary, for example. In this case, salary is a categorical high, low, and medium. What it's saying here is that the salary in the first row is low, right? So if I go up in here, well, you can see that the salary on my first row should be 2, right? Low, which is low, right? So this is showing me the index. It's showing me the index right here. Low is a second value, right? That's what it does. Well, it's very difficult to understand when you see it first, but it takes a while to get used to this notation. Class HR is going to show me that it's a data frame. Now, this one is data frame. Well, this one is going to check if this is a data frame, right? Now, what I can do is I can display the variable names. Well, you might be wondering, why do I need this? Well, sometimes I want to do something for each variable, right? I want to loop through my variable names, as you'll see it later. So here, names HR is going to return a vector of variable names. It's a vector, remember this? So here, what is this? Look, this is a vector of variable names. The first element in this row, right, is number 1. This one is number 4, right, is 4. 1, 2, 3, 4, right? So this is the position of an element, of the first element that is displayed in this row, right? Well, that's what it is. Everything is a vector. The list of names is a vector. And this is an alternative. I like to show you more than one way because, well, it's hard to know what you will see in the reading, right? Well, if you see names and if you see column names, you're going to know that they mean the same thing, right? Here, dimensions. Now notice that in this window, right, you see the size, you see the number of rows and the number of variables. But to do it programmatically, you run the im command. And if I'm interested just in the number of rows, this is n row. Or, watch this, dimension, this has 2 elements, right? This is the first element, this is the second. The first element is the number of rows, so I can just do this. And this will show me only the number of rows. Number of columns, I can do end call, I can do length, or I can take the second dimension, right? Second dimension, or, well, this is names, is going to return the list of column names, right? And I'm taking the length of the list of column names. This will also return the number of columns. So basically, if you get a pop quiz, just an example, and you're asked to display the number of variables, those are the 4 ways that you could do it. Now here, we're going to look at some descriptive statistics. I'm going to run the summary command, and it's going to show me the descriptive statistics for all 10 variables that I have, 10 columns, right? Well, satisfaction level, in this case, this is a numeric, right? So it shows me the minimum, the first quartile, third quartile, median, mean, and the maximum, right? For the categorical, it shows me the value and the number of rows that have each value. Department, since I have more than 6 departments, it's gonna show me, well, it shows the 6 dominant, right? Those are the dominant departments. And other is everything else. So it will show the 6 dominant only, right? Suppose that I had 2,000 variables instead of 10, and I'm a little bit lazy to scroll through. It's possible to show the statistics for only one variable. The way you do it is that you take the dataset name, and it's followed by the $, and then followed by the variable name. This is going to show the statistics for a single variable. Okay? Well, another way to show the statistics for another data, for the whole data frame, you run the lapply command. Lapply command, it applies the function, it loops through all your variables, and it applies this function to each variable at a time. So what this will do is it will apply the summary function to each variable, right? So this is just another way to do this, right? And the output looks slightly differently. Suppose that now I'm interested only in the minimum satisfaction level. So I use the min command, and I'm going to put the data frame name, $, and then I put the variable name, right? Okay. Now, one thing to remember is that all variables are case sensitive. So if I was going to put HR in the uppercase, I would get an error because I would get an unexpected result because I don't have capital HR, I have lowercase, right? What this will do, range, it will show you the minimum and the maximum. And this will show the standard deviation. Notice that the summary command does not return the standard deviation, right? This is what you'll do. Now, department. If you look at the summary, it only showed you the 6 dominant. But if I want to see all 6, right, I want to know what my departments are, I'm going to run the unique command. It's going to show me what departments I have. Or you can also do the levels, right? You can also do the levels. That's another way to see all of them. This command, I'm going to display the maximum satisfaction, but at this time I want to show it for department, right? So this is how you do this. You want to show it per department, when in this case it's 1, but I did the aggregate. This is a data set name, variable name. Well, and this, well, here, watch, I want to do it per department, so specify the grouping, right, variable. And the function is maximum, right, in this case. The highest satisfaction level per department. This is how you output the subset. You put in the brackets, you specify the range of rows, right, comma, followed by the columns that you want to select. If the columns are omitted, it's going to select every single column in the first 5 rows, like here. I did not specify the columns. It means that I want every single column, right? It's gonna do this now. It's gonna output. Alternatively, I could create a new data frame, and set it to the first 5 rows. I can assign it to the first 5 rows here, right? This creates another data frame here, it is. And I have 5 observations, 10 variables, that's what I just did, right? Here, if I want to take the first 3 variables, so I'm taking the variable at position 1 through 3, right? This is what I did here. Here, I want to do, well, the first 6, but this is another way to do it. I can do this, because names, this is an array of the column names, so this is just, it will return the same thing, the first 6, right? Okay, here I can specify which columns I'm looking at, and this is the number is a column position, right? First, fourth, and fifth. C is a list. Do you remember from early example? C is a list. Sometimes the list is used as an input parameter. In this case, C1, 4, 5. This creates a list of 3 elements, 1, 4, and 5. And here, what I'm doing is, I'm going to display the variable at position 1, 4, and 5, and the first 5 rows. So this is what's going to return. And here, I want to specify the variable name instead of specifying the position. That's possible too, right? So I put this C, it means the list, right? Here, I want to select all rows. Well, in general, that's not what you're going to do because the output is huge. When the output is huge, it's only going to give me the subset. And how big is the subset, that's determined in the options. Remember, we looked at the options, and one of the options tells me how many characters to show if the output is too large, right? So this is what's happening in here. The output gets truncated. It's because it's too many rows, right? Here, this is what I'm doing. This is a data frame HR. I'm taking the salary, right? And I'm displaying the first 4 values of the salary. What I could also do is I can do the conditional selection. I want to select all rows, but I want to take the rows only where salary is medium. So here I'm specifying which rows to select. So this is a conditional. Salary equals medium. And here, comma, right here after the comma, I need to specify which columns I want. In this case, the columns are omitted. It means I want everything, right? But you have to have a comma. Again, my output is truncated. It's because I have too many rows, right? Output is too long. And here, what you could do, you can combine more than one condition. I want the salary medium, and also I want the department HR. So this is going to be, well, less rows, match this condition, but still the output is too large. You can keep on adding conditions, right? You can do and or you can do or. Now suppose that I want to add I want to add new variable to the data set. I have number of years spent in the company. The time spent in the company is in years. And just for example, I want to calculate how many months. I want to track how many months somebody spent in the company. To do that, I would just put the $, and this is how I want to name my variables that I want to add. And here, well, what this will do is it will take the time spent, multiply by 12, and assign it. It will take this and it will assign it. This is a new variable that I want to create, right? It will assign it. I'm here now, right? Well, this will assign it, and then what you need to do is you need to verify your work, right? How do we verify that the new variable was added? One way to do that is to run the head command to preview the first 6 rows, because you also want to make sure that the calculation is correct. So you can look at the years spent, right? And you want to make sure that number of years times 12 is this number, right? you want to preview your data. Well, in this case, the calculation is simple, but in general, you're going to look at something more complex than this, right? Okay. Now, suppose that I want to delete the variable. The easiest way to do it is to set it to null. See this? Null. Setting it to null will get rid of the variable. And then I do the head command to display the first 6 rows, and it's gone, right? And I see that it's gone. The variable that I deleted is gone. Alternatively, I can just run my names command to list what variables I have, right? I can just list the variable names. Sometimes it might be easier, especially if I have a lot of variables. I don't want to scroll through. Now here is sorting. Sometimes you want to, perhaps you could display the users with the top 10 satisfaction score, right? Or you want to display 10 least satisfied people, perhaps. So that's when you use the sorting. First, you sort the data by the satisfaction level, right? And then you want to select the first 10 records, right? You want to select the first 10 records. So what you do is, in order to sort, you use order, and then in here you want to specify what you want it sorted by. In this case, I'm creating the new data frame called HR sorted, and I'm sorting it on the satisfaction level. But I want to select all columns. So here I did not specify the columns that I want to select, and this is the criteria for the rows. I want to order by the satisfaction level, and I think by default it's an ascending. Okay, so now what I'll do is I run this, right, and then I want to preview the HR sorted, right, and I want to make sure. Well, I'm gonna check the satisfaction level, and I want to see if it's sorted. But well, the problem is you have a lot of values. You have a lot of rows with the same value probably. So what you could also do, well, you could sort by 2 columns, like here. What I'm doing it, I'm sorting by the satisfaction, and also I'm adding the sort by the number of projects. So if 2 people have the same satisfaction level, the person with the highest number of projects will appear first, right? So this is what it's doing here. What else I could do it? Well, the default is ascending, but if I want to sort descending, I put a minus sign in here. If I put a minus sign in here, it's gonna sort descending, okay? Well, and the reasons for sorting are sometimes you sort to identify the duplicates. Sometimes the sorting could help you find the, well, 10 lowest perhaps, or 10 highest values, right? So that's the reason we sort. Here, this is a little bit more on a factor variables, right? So here we have a variable that's called left. For some reason, it was loaded as a numeric, but just from dataset description, I know that my variable left can have only 2 values, whether an employee left or an employee stayed, right? So in theory, this should be a factor. And suppose that I'm running a method that requires the dependent variable to be categorical. Well, the variables that I want to predict, perhaps I wanted to predict if an employee stayed or left. And the method that I'm using, you have to have the categorical, right? It has to be categorical, the variable I'm predicting. So this is what he would do, is he would convert it to the factor, right? Because we know, well, in this case, we know that this specific variable has 2 values, right? 0 and 1. So I can just go ahead and convert this. And then how do you know that the command works as expected? You run the summary command and you see this. Now my statistics have changed. I see my values, right, 0 and 1, and here's the number of rows that have each value. Also, I could run isFactor command, and it will show me that this is now the data type has changed to factor. what I also could do for my factor variables is I can display my frequency count. Here I did the summary, but here I can do the table command. I can also use a table command. Well, the reason for using the table command instead of summary is that sometimes I want to use it as an input into another command. Like here I want to see the proportion of people at each salary level, right? Here I want to see the proportions, right? The output of table command can also be used to build the pie charts, as you'll see later. And here, well, this is a cross tab where I want my columns to be whether an employee left or stayed, and here I want it to be every row is going to be my salary level. Now let me show you something interesting now. I want to calculate the average. I want to see the average, right, of the last evaluation score. And now I'm gonna run into a problem. And the problem is I have at least one row where last evaluation score is missing. And if I try to run something like a mean function on the column where I have at least one missing value, I'm gonna have this. It's gonna return NA. I have several options here. This parameter will say to ignore the rows where the value is missing and just display the mean, right? Well, this is very important because sometimes I want to replace the rows with missing values by the mean. So this is how you find the mean, right? You want to ignore the missing values, and this is gonna work, right? And ARM equals true. This is show me the average, right? Without mean. It is without missing. It's gonna omit the row that has a missing value, right? Here this will work. Now here are some checks. It will help you in a homework assignment. How am I gonna know if my data is missing any values? Well, isNA command, isName command is going to return the true if the value is missing. Well, what this will do, isNA HR by itself. Well, this is going to loop through the whole data frame, and for each value, if it's missing, it's going to return true. If it's not missing, it's going to return false, right? What any will do is it will check if there is at least one missing value in the data set. And if this return true, it means that somewhere I have at least one missing values. Now I want to dig further. I want to know how many values am I missing. This is the sum. So I know I have two missing values in the data set. Now I want to know how many values am I missing for the last evaluation. So here, well, I specified that I want to look at the last evaluation only, right? isNA, and I want to do the sum, right? And here I want to know the specific. I want to know which row is missing the value for the last evaluation, which is going to return the index of a row. Okay? Well, this will help you with a homework assignment where you ask to check if there are missing values, right? Then you ask to do something with a missing value, and then you ask to verify that it was done. I believe it's a next week homework. You ask to do something like this. So you will have a copy of this code. It's an example, right? Here, complete cases, this will return the rows that have all values. Complete cases itself is going to return the rows, a subset of rows, all rows rather, that have all values. This exclamation point means that give me the rows that have at least one missing value, right? Well, incomplete. So here, for the row selection criteria, I want incomplete. And here, I want to see all variables, right? I want to see all variables, but I want to see the rows that have at least one value missing. Then see this here, this is showing me, see this, remember, this is the row number 375, and this is missing the last evaluation, right? It's missing the see here it is, this is a last evaluation, it's missing. Then I have average monthly hours missing, right? So how do we handle missing values? Well, there is more than one way. Sometimes I can remove the rows that have I can remove the rows that have at least one missing value, and this is how you do it. And omit, this is going to eliminate all rows that have a missing values. Then this is another way, right? Like you saw here. Here I displayed the incomplete cases. Here it's gonna do the complete. It's gonna take all rows that have at least one. It's gonna take all rows that don't have a missing value, right? Well, there are two ways to do it, right? Now, well, the problem is I can lose my data, right? If I keep deleting, if I have too many rows with missing that are missing at least one value, I'm going to lose my data. I have an alternative here. I can replace my missing value with a mean. Remember this. Here, this is how you calculate the mean, right? I have to specify an A or M equals true. Otherwise, the output is going to be an A. So here I'm taking the mean of the last evaluation values. Here I'm going to check if the value is missing. Then I'm going to set it to average, right? To mean. Well, this is what I'm doing here. I'm going to loop through all values in the evaluation, right? And I'm going to check if it's missing, right? Is on A. It's gonna tell me if it's missing, and then I'm going to replace it, set it to an average, right? So let's do this, and let's set the average monthly hours. So now what I'm going to do is I can check, because remember the output of the summary command also showed if I have missing values, right? It showed the number of missing values as well. So now if I run the summary, well, it's gonna show me that there's gonna known, right? Right now I don't have any missing values. Or alternatively, I can go back here and I can run any command. I want to see that. Well, right now it's false because I already handled all my missing values. Well, this is something for you to, this is how you test. And this is another way, right? There is more than one way. Here it's going to show me how many values are missing for each column, right? Column sum, it's gonna look at each column. It's gonna calculate how many values I have missing. Now we're gonna get back to packages. As you may remember, I showed you in the beginning that the code is organized into packages, right? Every package, the package contains a set of functions, right? It contains a set of help pages, and some of them contain data sets, like data sets package. Some packages are installed. When you install the R, well, this is a system library. This is what comes with the installation. The thing is, some packages that you're gonna use to do the work are not pre-installed. Like a rules package, you're gonna use it for discretization, and you're also gonna use it in your third week to do the association rules. You will have to install it, right? But first, what you're gonna do, this is a command you're gonna run to open all the list of all available packages in the browser. So save this command, right? Library is gonna list all installed packages, right? This is gonna list you everything that you installed, right? So this is the user packages that you installed, and this is the packages that in the system library. Well, actually I install this, but well, you'll have to install the rules, right? And then in the next assignment, week 4, you'll probably install something else, or week 6 rather. You're gonna be installing the party well, you're gonna be installing the neural network, but that's coming. It's upcoming weeks. Don't worry about it for right now. But next week, week 2, you're gonna be doing a rules. You have to install a rules to do the discretization. Okay. Well, this one is gonna list what's in the memory, because after you install a package, the package is unavailable until you actually load it in memory. Search command is gonna show you everything that you have in memory right now. And at the moment, what I have in memory is just these packages that were pre-installed. This is going to list me the packages that I have in memory at the moment, right? Search command. Well, sometimes if you're running something like a function or something and it's not recognized, you want to make sure that the package where the function is defined is available, right? So you want to check what's in your memory at the moment. And here, this will show me where the packages get installed. So, well, here, this one is a user library. This is where it gets installed. So when you install your first package, you might be prompted if you want to create a folder. And you're gonna see the folder. This is your computer username, right? Well, Elena, but this is my childhood nickname. So, and here is a documents folder. Then here, this is R, subfolder R, Win library, and 3.5, right? So this is the main version, and 3.53 is a subversion. So if you install the earlier version of R very, very early, you probably have 3.4 subfolder in there too. But, well, this is a location of R libraries on your PC, right? And you're going to have, here you're going to have your computer username, right? Your PC username or nickname, whatever you used when you set up your system. And I'm on Windows, so yeah, Mac might be a little bit different. Here, well, I'm not going to run this command, but this is a command you do to install the package. Next, for the next homework and for the walkthrough, right? Next walkthrough, you have to run this command. And then here, there are two ways to load this package into memory. One way is to do the library command, and another way is to run require command, okay? Well, but notice here what I see is, well, this is a message. Well, this is in red, but it's not an arrow. This message is informative. What it tells me is that I have something in a rules package that depends on the package metrics. So when my rules package was loaded in the memory, then I had to load the matrix package as well. And here, well, what it's telling me here is that my rules package has a couple functions in the same name that base package. So if I was going to call write command from the base package, I would have to qualify the function name with the package name, right? If you have more than one package that contains the same function and both are in memory, you would have to qualify the function name with the package name. That's what you will do, right? Well, this message is informative. You may ignore it for what you're doing, but I like to explain to you what it's doing. It's telling me here that, first of all, I'm loading matrix in memory as well, because there is something in a rules package that depends on matrix. And here it's showing me that my package that I put in memory has the same methods that this package, right? On the other hand, if I run require command, I get less information. See this? When I use the require command, well, this information was not shown for me, right? So basically, that's the main difference. Here, you can open up the documentation page. Okay, here's the documentation page. That's one way to do this, one way to see it. Or you can also see this package. This package contains vignette examples. So this will open in a separate window. This is very good for the week 3. Well, you want to read this thing here. Well, it's gonna be your browser, whatever your default browser is. In my case, apparently it's Windows Explorer, and this will open this help file in the browser, right? This is rather VNet, and this is a article about the rules package. Well, it will help you in week 2 also because it does the discretization. Here, well, I'm not gonna run it, but this command updates all packages that you installed. Once in a while, you need to run it. Well, I got into a habit of updating my libraries weekly. This is how to do it programmatically, but you can also run click the update in here, right? There's more than one way. Here, detach command is going to unload the package from memory, and remove is going to remove, delete, right? Deletion. Here, as I mentioned here, R has very interesting visualizations. So here, this will show me the histogram for the average monthly hours variable. Now, the histogram is good for numeric variables, and it's going to show me the distribution. This is a plot stub, and it shows me the distribution. Since, well, one of your homework questions is to show the histogram, right? But Tia Yelena was an A student, right? An A student will usually go beyond what's asked. And how am I going to go beyond in here? I can use the input parameters, right? For instance, if I specify break, it's going to attempt to break this interval into 20 bars, right? That's one way, right? Also, I can change the border, right? Well, this is what you can do for your homework. Don't just rely on the default. You can specify the border, you can specify the color, or you can do multiple input parameters. Impress your instructor, right? I want to do the color, I want to do the density, I want to specify the number of intervals, the number of breaks rather, right? And I want to specify, I want to rename my x-axis, perhaps, right? And also I could use the argument called title to change this here, the diagram title. Well, so you want to do is in your homework assignment, when it says to put the histogram, right, to build the histogram, it's okay just to put one variable, right? But if you want to go beyond, and if you want to learn R more in advance, you want to take advantage of some parameters, right? Okay, and here what I could do earlier, remember I mentioned that the tables used as an input for the visualization. There are two ways to do it. I can store my table in a variable, and then I can display, right? This is my table of the salary, and then I can do the bar plot like this. Well, this is a bar plot, but of course, if you were doing it for the graded assignment, probably you want to add the title, right? You want to add the axis name, you want to probably do the color codes, and etc., right? Alternatively, I can put here as an input parameter, right? I can put this here, right? I can put it here. I can put it, instead of creating a separate variable, I can just put table salary in here, right? Now what I'm going to do is I'm going to impress the instructor, right? Or I'm going to impress my audience. What I'm doing here, I want to order, right? I want to order this by the number of rows, right? So here the counts, right, is the number of rows, and I want to sort it. This will do the sorted bar plot. Well, if I was doing it for my homework, I could further impress my faculty, my teacher, right? I could do the horizontal bar plot. Well, here I can do sorted horizontal, and so on. So do not limit yourself to the defaults, right? You want to explore the colors, you want to explore the fonts, you want to do the titles, and so on. Do not limit yourself. And here, this is how you do the pie chart. Well, if you were doing it for the homework assignment, you probably want to explore the colors. You want to explore where the labels are positioned, perhaps you want to show the percentages. You want to change the color codes. You know, this is default colors. You can specify the colors, etc. Right? So pie chart is good to show the distribution, but it's not always readable, right? If you have a large number of values, it might not be readable. Here, this is a box plot. This works well for numeric variables. Here, well, this is not gonna look well. This is a generic plot function, right? This is generic. Here, this is gonna do the line. Here, this is two categorical variables, right? This is what it's gonna do. It's trying to, based on the data type, it's trying to determine what I want to do. Well, here, this is one variable. Well, of course, this is not what I want, but I'm just showing you what happens. See, this is not what I want in this case, but I'm just showing you why you're gonna use this, right? So now I'm gonna show you the fun part that I called bonus. There is a web page called Cognitive Class. You can set up your account for free. Some of you may have used it in long time ago. We used it in the Data 610 to take the introduction to what's an analytics course. But this web page has other courses: introduction to R, machine learning with R, data visualization with R, etc. So this is what you could do to further enhance your skills if you want to, right, at your leisure. And here are some additional tutorials. Well, keep in mind that sometimes the web page URL subjects to change, but some of it is in your classroom also. There are some interactive tutorials, and there is a LinkedIn group. There are a couple of LinkedIn groups I would recommend you to join, and you can find a lot of interesting articles in there. Okay, and here are some more URLs that you may consider adding the bookmarks. So here, this is a good one: rdataMining.com, RStudio documentation, and there are also free R books. There's some free R books. There is a free RStudio community that you can join. Sometimes you might not be sure how to do something. There is a R Q&A web page, right? So here are very good resources. Now, what else I did for you is I put a summary of what we discussed today. You will have a copy of this deck of slides, and you will have a copy of the R script, right? You'll have a copy of the code. After this, I'm gonna send your faculty the link to the recording. I'm gonna send you the slides and also the R script, right? So here, I just want to make sure that I covered everything that's in the slide, because usually I'm not reading the slides. As you saw, I just do the speaking, right? I speak, but I want to make sure that everything that I hear is covered, right? It is, looks like it is, yes. So here, well, this is a command for the packages. This is how to work with packages, and I summarized it for you. It's also in the script, right? And then I put some notes for you. When would you use each visualizations? Well, this is really helpful when you're analyzing your data, right? And sometimes, well, you know, you have a lot of visualization, but how do I know which one is suitable for my variable? So here are some key points to keep in mind, right? Oh, another thing I forgot to mention is that, well, I showed you how to remove the variable, right? I showed you how to remove the variable. Some of you might be wondering, why do we need to remove the variable? Well, the reason is sometimes you could have the sensitive information in the data, like social security numbers or people names, right? That's when you remove the variable. Sometimes it could be the unique identifier. They slow down the data mining methods, so you want to remove that. Sometimes you could have a variable that have the same value in every row. Perhaps I'm analyzing a subset of employees who live in Maryland, and the state is Maryland for everyone, then I can remove it. Sometimes my variable could be missing most of the values, well, then I don't want to delete all rows missing a value. I would rather consider deleting a variable, right? Or sometimes you want to look at the distribution, right? If it's skewed. For instance, I can have one person from Virginia and everybody else in Maryland. So looking at the state is not going to be helpful, right? Well, there are multiple reasons, but I just listed you some. So this might be a good question, and you may see it. But let's see what questions you may have. I was speaking for like more than an hour. I love when people ask questions. So let me go into the chat. Well, okay, I'm gonna open the chat. Nobody asked any questions, huh? Let me see who has questions. I love questions. Questions. I really like questions, and I like students who ask questions. Okay, if you are creating a variable and you want the variable or column to be positioned before another column, do you need to specify the position? Well, that piece, I don't think there is a way to specify the position, unless you want to create a totally brand new you want to create a totally brand new data frame where you're going to select first two variables, then add a variable that you want next, and then add the rest. But explicitly, I'm unaware if there is a way to actually reposition. I'm unaware of it, but if I find it, I'll let you know. But this is interesting how it is. It's reading it in the same order that it is in a CSV file. So yeah, but yeah, the position it's a vector, right? The list of column names is a vector. Yeah, but that's an excellent question. Excellent question. You specify, yeah. So basically, yeah, the names, you run the names command, right? And it will give you the position. Yeah, but I'm unaware if, well, there is a way to reposition. You would have to take a subset, then take the column in question, and then take the rest of the columns. Yeah, that's one way. All right, let's see if we have more questions. I love questions. So I give kudos to people who ask questions. Anybody else? Anybody else? So, but when you're creating a brand new data frame, right, you would specify, yeah. But in my case, I was reading the data from the file. This is what you're gonna do in your second homework assignment. And in the walkthrough, you're gonna be reading the car's data, right? Yeah. The car safety level, the mileage, yeah. Well, that's a car's data that you're gonna use for the walkthrough, and credit approval data that's gonna be for the assignment, right? Yeah. Well, did any of you started looking into the homework? Well, that's a good time to ask you questions. Well, everybody understands how to create a first script, right? The comments, how to add comments, etc. So let me open up the chat again. Yes, you've been working excellent. Yes, you want to start working on the exercises as early as possible. Something else I want to bring up. Each exercise instructions have a time estimate. So if it says that on average it could take 3 to 5 hours, it means that it's a time that you spend during the week, right? Do not expect to be able to start working on exercise at 7 p.m. on Sunday to meet the 11:59 p.m. Exercise due date. Do not do this. This is not how it works. So 3 to 5 hours does not mean that you can start at 7 p.m. on Sunday night and be done. No, this is the time that you need to spend throughout the week. So just beware of that. I wanted to point that out. And the estimate is based on questioning the A and B students. A lot of the respondents were B students. So how long it took for them to do the exercise. Well, it's a, okay, can you ask a question? Well, you can post on the discussion board, then it's everybody else will see it, but you can also ask me. Go ahead and ask, yes. Well, I can see the nature of a question, and then everybody will have this recording, right? So it's a fair game. Yeah, go ahead and ask. Not a problem. Okay, so part one, each comment, well, basically, yes, for part one, what you want to do is you want to turn in a script, right? And also you want to take a screenshot of what the command returns, because part two asks you to explain, right? So basically, part one, you write in the script and you will turn on the script, but in part two, you need to take a screenshot because the question asks you to explain the output, right? So here is my screenshot and here is my output, right? Like for example, if I'm asked to run the head command, right? So I'm running the head command, this command is in my script, and then I'm going back in here in the console, I'm taking a screenshot of my HR command, right? The output, and this is what I'm gonna put in my write-up. I'm gonna put a screenshot of this command and this output and an explanation. Yeah. Yeah, I'm glad. Oh, but here's my question. Yeah, go ahead, type the question. Yes, go ahead. Go ahead. Not a problem. So it says to run the entire script. Oh, well, you may run the command at a time, but, oh, well, that's an excellent question. If you cannot display everything in a single screen, then, well, you take screenshots of a command at a time, not a problem. But basically, the reason you need the screenshot is because the second part, you have to explain what the command returned. If it does not fit in a single screenshot, then here you take a command at a time. And here, what you could also do is this. You could adjust the window, right? If I adjust the window, yeah. Oh, and by the way, something else I forgot to show you is that you can use up and down arrow. Using up and down arrow, you basically navigating through the commands history. So when I click the up arrow, it's going to show me the command I ran last. So I'm going to rerun this command, and basically, well, it's supposed to show me. It's supposed to show me it's going to resize the output. I'm not sure what's going on now, but well, it's supposed to resize anyway. Yes, it's here. See, this is resized. Okay. So okay, let's see. But the output of the plot. Oh, well, yes, that's right. If okay, well, to take the screenshot of the plot, right? So here is my plot. Let me find something nice. And this is how you navigate through plots. You're gonna click on the arrows. When you click on the arrows here, this is how you navigate, well, between the plots. Well, take a look what you can do. You can just do this. You can do export, and you can save an image, or you can do this. See, this is my visualization. I can do export, and I can copy this to the clipboard, and then I can paste it to my Word file. This is what you do. Yeah, resizing is excellent. But to take a screenshot of this, see this? Well, I can do this. I can copy to clipboard, and see, this is my visualization that I want to paste. I can copy this to clipboard, and then I can paste it to Word. And I can also save it as an image and then add an image to Word. Or, well, in Windows, you have this you have the snipping tool. That I usually use the snipping tool to take my screenshot. Okay. Oh, okay. Yeah, excellent. Yes, the clipboard, yes, it's a nice feature. There are a lot of hidden functionalities that are not obvious, but that's a reason we're doing the walkthrough, because some stuff is not obvious, but you know, it's good to see multiple ways to do something. You might see one way, but the TA shows another way, another TA would do differently. Well, do what works for you. See, you can do copy to clipboard, but for the help here, you cannot. Well, you would have to use the way you usually take screenshots, right? In Windows snipping tool, but in Mac, I'm not sure how to take in Mac, but the way you take screenshots in Mac, same way you would do this. Okay? Any more questions, please? I like questions, guys. Guys, I love questions. Questions. Questions are good. Oh, for Mac? Oh, it's Control Command and number 5. Excellent. Thank you for letting me know. For Mac, to take the screenshot is a command and number 5. Thank you. Well, no, this is really useful because, yeah, I'm a Windows user, so it's good to have Mac users who would know how to do that. Anyhow, more questions? I love questions. Okay, and if might be curious, yes, I'm the same Yelena who managed the Watson Analytics accounts in DataFrame. Yeah. So, yeah. So, questions, if there are no more questions, then what we'll do is, here is the deal. I'm going to stop the recording and end the meeting. Oh, okay. Are those accounts good for, yeah, correct. Oh, those accounts are still good. I think they expire at the end of June because we are transitioning to a new software now, Cognos Analytics. Watson Analytics will be removed from the market. But your account is you still should have access for another month, I think. Yeah, but we are transitioning to new software in DataFrame starting from the summer. Yeah. Cognos Analytics. Yeah. So, but for the R, you install R, right? For this class, you install R to your PC, and you have to have the admin rights. Okay? Yeah. All right. So let's do this. I'm gonna end the recording. I'm going to stop the recording, and I'm going to send the recording to your professor. Wait, stop recording. And it says yes.